Hello, everyone, and welcome to AI in Trading course. My name is Esfan Hagverdi, and I will be teaching this very first course that is being offered on the Quantopian Community platform. So this is lecture one, introduction, and our goal here in this course is seeing that AI has become pervasive in almost every field of knowledge. Many people have already, of course, started using AI in the field of finance at large and trading in particular as a subfield of that. And so what we're trying to see is if we can build enough background and knowledge from the AI side, in particular machine learning, as we will see, for the particular purpose of using it in trading. And for those, we need to have a closer look at what AI is, what our understanding of AI is, and what the subfields of AI are, and what is it that these new techniques and tools offer. And then certainly in order to be able to apply any of these techniques and tools to solve the problems in finance and in trading in particular, we need to have a good, precise understanding and formulation of the problems that we are trying to solve. So a couple of questions immediately arise when you look at the application of AI in finance. So you can naturally ask if finance is a distinct field for applications of artificial intelligence techniques. By this, I mean, is it the same as computer vision? Is it the same as any other field, image processing, object recognition, speech recognition? Or is it a field that offers, because of idiosyncrasies, some other features that may challenge AI? Another immediate question is, we see that in particular in computer vision, speech recognition, in various fields that deep learning and neural nets are being used, that we are in the realm of big data. We are dealing with billions, trillions of data points and features. So is finance really within the realm of big data? There are certainly areas of finance like high frequency trading where the scale of trading is certainly offering big data level availability of features and data points. But on the other hand, we have the macro level considerations in trading, and we can't easily say that falls into their realm. And so there may be different areas of finance and even within trading, different areas of trading for which we need different techniques of AI. Next question we can ask, are AI techniques more useful than classical econometrics? So this is, I think, a very important question to ask before jumping on the wagon and trying to use any fancy or fashionable tool that are currently being used in your field of interest, is to understand and ask the question, well, I already have some tools in my field, namely in this case, one of those areas is the classical econometrics. So are these new techniques offering anything new? Are they telling us things that we couldn't already get using the tools of classical econometrics? What about constantly changing and evolving markets? Markets are constantly changing, they are evolving. Many of you have heard about adaptive market theory and hypotheses. So these regime changes are things that may challenge AI. And if so, how can the tools that we're using adapt to that kind of evolving and constantly changing markets, and in particular also constantly changing maybe buyer and seller behavior? So there may be other challenges that I haven't listed here, but many of you may think about other challenges or try to think about other challenges that the application of AI in finance may face. You know, we have heard all the time that in finance, there is a very low signal to noise ratio. So that could be a challenge for some of these techniques in AI with their applications to finance, among other things. So I just wanted to, so this is just a partial Google search for books on applications of AI or artificial intelligence in finance with different titles and variations of titles. But you can see already that there are many, many books being written. So it's not so easy to pick the ones that we really like or the ones that are really useful, or then find an area that we're going to apply and find the technique that we are going to apply to that area. But we're trying to choose some of these books, 3 to 4 of these books that we're going to follow very closely in this course. And I just wanted to say a few more words about our approach in this course. I really like a more foundational approach as opposed to jumping into a particular technique, a particular computer software, and applying it to a collection of data and getting some results and being either happy or sad with that. I think that a foundational approach that teaches us the fundamentals of these techniques that, or the mathematical foundations of these techniques, will be ultimately much more productive at the time when we try to narrow down to a particular technique based on particular assumptions and apply it to a particular problem. Um, we start therefore from basics. We are not going to assume much in terms of background, certain, of course, mathematical maturity, even though we are not going to become too theoretical or mathematical, but a certain mathematical maturity in understanding the symbolic manipulations and statistical concepts will be required. But beyond that, we're going to start with the very basics and build our way up. We also emphasize understanding the problem, and this may seem very trivial, that certainly you cannot solve a problem without understanding the problem, but in practice, oftentimes this is a forgotten item that we tend to jump into solution or a technique for solution of a problem without having understood all the details and the nuances of the problem. So we're trying to always motivate from day one in this course. What is the problem that we're trying to solve? What are all the items that are mentioned in this problem? Do we know the definition of all these problems? Do we know the constraints of the problems? And what is being asked? What are the things that we can use, and so on? And we definitely want to emphasize the limitations of the techniques that we will be using. No technique in particular in the field of data science is universal. There is no one technique that will solve all problems. Every single technique has its own limitations and its own areas of excellence and areas when it performs rather poorly. So that is another point which we will emphasize throughout the course while studying these new techniques. And finally, I think one of the most important things is, again, things that are neglected most of the time are the assumptions, in particular hidden assumptions, assumptions that remain hidden because they are not challenged, or assumptions that are so taken for granted that oftentimes are forgotten. So you may dive into a particular solution technique without realizing that the underlying distribution is a Gaussian normal distribution, and that particular distribution may not fit the particular type of data that you're interested in. You may try to use a particular fancy mathematically sophisticated technique of data science or machine learning without thinking about the assumption underlying that technique that requires that data be distributed over a smooth surface. And the type of data that you have, at least you have no reason to believe that it is distributed over, say, a smooth surface like a sphere, or the higher dimensional equivalence of the sphere. So these all will impact, of course, the results that we see, the degree of precision in the solution to the problem that we see, the appropriateness of the technique for the problem, and so on and so forth. So these are all the things, among others, that we will emphasize in this course as we proceed. And thank you very much for listening. This is the end of the first lecture, and I hope to see you in our next lecture. Thank you. Bye.